Hello dear students, welcome back to my YouTube channel chalomathspadhne. Dear students, we have a question of three-dimensional geometry, question of a straight line. We have given two straight lines and we have to find the shortest distance between these two lines. How we can solve it very easily? Watch till the end and share it to your friends. Okay, let us start. This type of questions are important for the students who are preparing for board examination of class 12 and the students who are preparing for competitive examinations. Okay, we have given the equations of two lines in vector form. First line is r vector equal to I cap plus j cap plus lambda times of 2 I cap minus j cap plus k cap. Let this is a1 vector and this is b1 vector, and another equation of line is r vector equal to 2 I cap minus j cap plus k cap plus mu times of 3 I cap minus 5 j cap plus 2 k cap. Okay, let this is a2 vector and this is a b2 vector. Okay, first of all, to find the shortest distance between these two lines, we should require, we know that the formula of shortest distance equal to in mode a2 vector minus a1 vector dot b1 vector cross b2 vector by magnitude of b1 vector cross b2 vector. Okay, so we need to find a2 vector minus a1 vector and b1 vector cross b2 vector and its magnitude. After this we can find the shortest distance very easily. Okay, so first we should find the uh, a2 vector minus a1 vector. Therefore a2 vector minus a1 vector is, how we can find? Subtract a1 vector from a2 vector, then we get 2 I cap minus I cap, we get I cap minus j cap minus j cap. What we will get? Minus 2 j cap and k cap minus 0 k cap, means k cap only. Okay, and now we find b1 vector cross b2 vector, and b1 vector cross b2 vector can be obtained by using the determinant. We know that it can be obtained by I cap, j cap, k cap, and components, scalar components of b1 vector are 2, minus 1 and 1. So we write here 2, minus 1 and 1, and scalar components of b2 vector are 3, minus 5 and 2. So we write here 3, minus 5 and 2. Okay, now we solve this determinant and we find b1 vector cross b2 vector. If we eliminate these rows and columns, then we get minus 2 minus plus 5. This we get 3 I cap and minus 4 minus 3 1 and minus j cap, and here we get k cap times of minus 10 minus plus 3 means 7. Okay, minus 7 k cap, right? You can find by using the method of determinants. Okay, you know determinants from algebra. Now we required here magnitude of b1 vector cross b2 vector. So first we find b1 vector cross b2 vector magnitude, then we get here 9 and 1 and 49, and this is what? 59. Okay, 59 under root 59. Under root 59 is the magnitude of b1 vector cross b2 vector, but we need to find the shortest distance between these two given lines. So we write here, by using this formula we can find the shortest distance, but before this we write shortest distance equals to a2 vector minus a1 vector dot b1 vector cross b2 vector by magnitude of b1 vector cross b2 vector. Okay, this is the formula to find its shortest distance between them. we use this formula and we put these values a2 vector minus a1 vector, b1 vector cross b2 vector, and magnitude of b1 vector cross b2 vector at the place of this. Okay, then we get a2 vector minus a1 vector is obtained here I cap minus 2 j cap, I cap minus 2 j cap plus k cap dot b1 vector cross b2 vector is obtained here 3 I cap minus j cap, 3 I cap minus j cap and plus minus 7 k cap, and magnitude is also obtained under root 59. Okay, under root 59. Now we know that the scalar product of two vectors is x1 x2 plus y1 y2 plus z1 z2. So we write here directly 1 into 3 3 and minus 2 into minus 1 plus 2 and 1 into minus 7, this is minus 7. Okay, and we get here under root 59. Now we find it 5 minus 7, this is minus 2, but this is in modulus, so we write its absolute value, means 2 by under root 59. This is the correct shortest distance between two given lines. Okay, I hope you have understood it. Thank you very much.